and reducing costs in AWS. Now, for our agenda, we'll begin with the Amazon Virtual Private Cloud. That's really the foundation of networking on AWS. Then we'll move on to talk about VPC endpoints. When you're building VPCs, you may run into some architectural designs that you could actually improve, save some costs, and design a little better. We like to call that the well-architected framework. So we'll talk about how you can utilize VPC endpoints with either gateway endpoints or interface endpoints. And then we'll move on to talk about some common use cases, and I'll provide you all with some resources that you can take away to learn more. Now, let's talk about the Amazon Virtual Private Cloud. Now, what is a VPC? A VPC, as you can see, is basically a data center that you have access to that is private to you in AWS. In here, you can store your resources, like your virtual machines. You have access to create a range of IP addresses, subnets, your network topology. How do you want to design your subnets? Multiple subnets, public subnets, private subnets. And then you also can control your routing within your VPC and within your cloud infrastructure, as well as your security rules. You can leverage things like security groups, which I'm not going to talk about because I'm not going too deep into that, but you can utilize security groups to control access to your EC2 instances. For those of you that don't know what that is, that's basically a virtual machine that you deploy into your VPC. And you can also use network access control lists that you can use to manage access to your subnets or your VPC CIDR blocks. Now, I want to get it started with AWS or the VPC. You have your AWS Cloud, that's going to be your account. When you log into AWS, you're accessing the AWS Cloud. And then from there, before you actually create your VPC, you'll select which region you want to deploy or create your VPC in. Once you do that, now your network services or your services like your EC2 instances get deployed or launched into your VPC. Outside of your VPC, we also have public services like Amazon DynamoDB and Amazon S3, which is object storage. That's going to be something that you'll have to know when it comes to creating networks on AWS. Which services actually are inside of the VPC and which services are outside of the VPC. And we can kind of go over that in this next slide. So when we actually create our VPC in a region, we have the concept of public subnets and private subnets. We also have the concept of availability zones. Look at a region as a geographical area like Virginia. We have US East 1. Or in California, we have, or Oregon, we have US West 2. Those are regions. Now within regions, we have availability zone, which are geographically separate on fault lines. So if something happens in that region, that availability zone will still be available for the services that are, or subnets that are in that availability zone. So here we have two availability zones with a public subnet and a private subnet. Now let me explain what's the difference between those two. So in those subnets, we create our launch our instances into those subnets. And then from there, in order to establish communication to the services outside of our VPC, which we call public services because they have public IP addressing, what we're going to do is create a route table for the public subnet that points to, here we call that IGW or Internet Gateway. And I'll show you what that looks like here in a moment. In our private subnet, we'll have a route table that if you need communication to public services, you're going to go through a NAT gateway. NAT versus IGW or Internet Gateway, the difference is NAT, you can't access from outside the internet, from the internet. In an Internet Gateway, you're able to access the services that are in that public subnet. Now, here we attach an Internet Gateway. So now the public subnet instance A, can access those services that are public on AWS, like Amazon S3, DynamoDB. And then from there, we can access the internet as well. Now, for our services that are in our private subnet, what we're going to do is create a NAT gateway. This allows us to hide our private subnet IP addresses behind that NAT gateway and still be able to talk to the internet as well as the public services on AWS. Now, with the NAT gateway, when we talked about reducing costs, you're charged per hour of running the NAT gateway. And with the internet gateway, you aren't charged to run an internet gateway, but you are charged for the data transfer out of AWS. So that's something to keep in mind. Now, I mentioned those are private subnets because they have a route to the internet gateway. And these are route tables. This is the private route table. This is the public route table. Now, when we're connecting to services within AWS, there's a couple ways we go about this. We may go through the NAT gateway or internet gateway to connect to the public services. We may peer VPCs to connect to a shared services or services that we're actually hosting and the services need to talk to each other. And we also can connect to third-party services that are in the AWS marketplace. We can do this through transit gateways or VPC peering, depending on how we design it. But this isn't always the best approach. With the transit gateway, you're going to be charged per hour of the transit gateway. You're also going to be charged for that inter-region transfer. And then with the VPC peering, if you're outside of to another availability zone or region, you'll be charged for that as well. So the question is, how can we architect this better? Well, one way to do that is going to be VPC endpoints. I like VPC endpoints because they kind of simplify a lot of network architecture. You can do this through a distributed architecture or centralized, and we'll kind of go through this as we go through our presentation. Now, what is a VPC endpoint? It provides you private connectivity to public services. Now, that service could be public to AWS. That service could be hosted through a third party on AWS Marketplace, or that service could be a service that you have in another VPC that you need communication to. So we'll kind of go through that here in a moment with those different types of VPC endpoints. We have two types. The first is going to be gateway endpoints. Then we also have interface endpoints. Let's start with our gateway endpoints. And I'll kind of slow down here. So I mentioned when you're communicating to Amazon S3, you need to go through an internet gateway since it has a public IP address. Well, what if you have guidelines for your private subnet, your EC2 instances that are on the private subnet, and you don't want those to actually go and have access to the internet. Of course, you can control this with security groups, but you can save costs by removing the NAT gateway and using a gateway endpoint and just allowing that private subnet to communicate directly to the gateway endpoint. And so here's how that looks without a gateway endpoint. The private subnet here is communicating with the NAT gateway that talks to the internet gateway, then talks to Amazon S3. I mentioned you're charged for the per hour cost here. And then you're also utilizing the public internet. You may not want to traverse that internet. So in order to design or create a gateway endpoint, here's what we do. The first thing we do is in the AWS console or from the AWS CLI or the Terraform. But here we have an example of creating in the AWS console. We'll create a endpoint. We'll select the AWS services since it is S3. And then we'll, under the services, we'll tell it S3, and then we'll select gateway. With S3, you have the option to do interface endpoints or gateway endpoint. The gateway endpoint is going to be attached to the VPC. The interface endpoint, which we'll talk about here shortly, will actually be an endpoint inside of your subnet. There's differences in between the two. Now, once you select gateway endpoint, which I don't have shown here, the next thing you do is select the route table. So that's going to be the private route table. And once you select that private route table, what happens is you actually get a prefix list in that route table that points to AWS networks or S3 and DynamoDB, those public services, but you have that private connection that doesn't traverse the internet gateway. And here's how that looks with gateway endpoints. I noticed that we have a route in our private subnet route table here. That's a route pointing to the VPC endpoint, which is there, and then that gives us access to S3. So rather than having to go through in that gateway, the internet gateway, now we can communicate directly with S3 using the standard S3 address or the address of the S3, since we have the route in the route table for the private subnet.
That will also reduce latency.
It could. It could. The thing about your NAT gateways is, depending on how your network is designed, is here we have 2 availability zones. You may be trying to cross availability zones to go to another NAT gateway, which goes to the internet gateway to S3. Now you have a VPC or gateway endpoint connected to the VPC, and you have that access directly to S3. Now, what about private connectivity to other services outside of Amazon S3 and DynamoDB? That's when we begin to talk about VPC endpoints, or specifically interface endpoints that are powered by PrivateLink. Now, what is PrivateLink? PrivateLink is what powers that private connection to those AWS services and those third-party marketplace services and the services that you create that you want to expose either to other VPCs, to other customers within AWS. It gives you the ability to access a service in another VPC using that private IP address. One of the challenges with architecting networks in the cloud is some of the same challenges we face on-prem, like IP address overlapping. I've ran into that multiple times in my career, and some of the ways we get around that is with NAT. Well, now with VPC endpoints, interface endpoints, we can kind of remove that and leverage DNS. When I talk about the architecture, what actually happens is when you create that interface endpoint, that endpoint goes into your subnet. So once that endpoint is in your subnet, now it looks like an IP address that is in your subnet. And then you also get a private hosted zone DNS address that you can communicate directly from that private subnet without traversing the internet. An additional thing about PrivateLink, it uses the concept of provider and consumer. So if you want to expose a service, you are the provider, and then you have consumers that consume your service. And we'll kind of show some diagrams to simplify this as much as possible. So what are some building blocks of PrivateLink? First is going to be your interface endpoint. That's why I mentioned that when you are a consumer, you create your interface endpoint, and that's going to be in your VPC. When that happens, that interface goes into your VPC. It gets a private address of that subnet that's in your VPC. And then you also get a private hosted zone DNS address that you can access from within our VPC. I mentioned the additional services for interface endpoints. Here are a list of services that we have that from AWS that you can actually utilize to set up VPC interface endpoints. There's a lot more. Now, when I talk about these additional services, I mentioned if you want to access Amazon S3 and DynamoDB. For example, let's say you need logging for your subnets that are in the private subnet. Rather than creating a NAT gateway in an internet IGW, what you could do is use a VPC endpoint for CloudWatch and then set up logging for those instances that are in your private subnet.
What's an IGW?
Internet gateway.
Oh.
Yeah, I said it at the beginning. I got you. Now, moving on, I mentioned the private DNS. Here's an example of what that private DNS looks like for you to be able to access from within your private subnet for that interface endpoint. And here's our architecture without the interface endpoint. I mentioned previously, the same scenario with the gateway endpoint is that from your private subnet, in order to communicate with SQS or the Amazon Simple Queue service, what we would have to do is go through a NAT gateway, through the internet gateway, which is going to be traversed through the internet with the public IP address to access the service. Now, with the interface endpoint powered by PrivateLink, what we would do is create the interface endpoint, select the service, which in this example is going to be SQS. We're going to tell it the interface type, which is going to be interface. And then we're going to select our VPC that we want to create the interface endpoint in, and then the subnets. For high availability, what you would do is create an endpoint in each of your subnets. At that point, we select our subnets. We enable DNS so we can communicate with the DNS name of that endpoint. And then we select our security groups. That's not listed here, but we actually can select our security groups for additional security to say what can communicate with that endpoint, because it's an ENI. Just like accessing a EC2 instance or that virtual machine that I mentioned, those ENIs leverage security groups to be able to control access to that virtual machine. You can do the same thing here with interface endpoints. And once we create our interface endpoint, now, rather than using the network gateway and traversing the internet, we leverage the ENI, leverage PrivateLink, and then talk directly to the service. And when we talk to that service, like I mentioned before, we can leverage the IP address that's in our subnet, which is here, or we can leverage the DNS name of that service. So that prevents the IP address overlap, some of the challenges that we have, along with the challenges that we have of managing our route tables. Because if we're leveraging VPC pairing or transit gateways, managing route tables can be a challenge. And if you know anything about a VPC, you can only have 1,000 routes in a VPC route table. 1,000 or 100. Well, I think it's 100 actually. 1,000. Yeah, it's 1,000. So.
Big difference.
Yeah, that's why I got it right. Now with PrivateLink, you can also expose your own services. Like I mentioned before, let's say you have a database that you want to expose, or you have a login server that you want to expose. What you can do is in your VPC, your provider VPC, create your service in multiple availability zones, use a network load balancer to provide that service. And then the front end of that network load balancer will communicate with PrivateLink. And then from there, in your consumers, you will create your VPC endpoints in your consumers.
Just so they can see that you're pointing at. There you go.
Awesome, thank you. Now, I mentioned the shared services. I mentioned gateway endpoints and leveraging interface endpoints. Something else I want to mention is communicating from on-prem to VPCs that are, let's say, peer to another VPC. A VPC is not transitive, meaning that you can't route through a VPC to another VPC. So if the corporate data center wants to talk to this VPC, it's not going to be able to, because it can't route through the VPC that direct connect is connected to. So what we can do with PrivateLink is, in this example here that I'll show in a moment, looks like it's coming up. We'll talk about that in a moment. Looks like my slides got messed up. Sorry about that. We'll talk about that in a moment. Now, I mentioned with VPC endpoints that we can leverage security groups. We can also use endpoint policies. So we can attach a policy to a VPC endpoint to say what can actually communicate with that service. And here's an example of a policy. So we have a policy that's attached to a VPC endpoint. We're saying the actions that are being able to be taken on that object. And then we're talking, we expose the service, the buckets that we can communicate with to get objects and put objects. So we can get the object and we can add to the object. Now let's talk about some common use cases. In the beginning, I talked about this slide. In this slide, we talked about using the NAT gateway to communicate to public services. We talked about VPC parent to communicate to shared services. And we talked about communicating with third-party VPCs by leveraging the transit gateway. With VPC endpoints, now we can just use VPC endpoints to communicate with AWS public services, shared services, and third-party services that are on the AWS marketplace, or maybe we have some customers that we partner with and they want to expose a service that we can consume. And here's an example of a SaaS provider wanting to expose a service to a consumer. Notice here that there's IP address overlap with the private subnets. So they're not going to be able to communicate unless we use some type of NAT or IP address for this communication to happen, or go over the internet, or create some type of VPN tunnel over the internet. But that's extra overhead that can incur some extra costs. A way to make this communication possible is to leverage VPC interface endpoints with PrivateLink. What we do in our provider, leverage the NOB or the network load balancer. Then from there, we expose our service. Now, our customer 1 and customer 2 can consume that service by leveraging interface endpoints. And their IP addresses don't change. They just use that DNS address. And then this interface endpoint has an IP address in the subnet that they're in. Here's the architecture that I was talking about from on-prem. Notice on-prem, on-premises, the on-premises data center is trying to communicate with the private account. But since the VPC consumer account is not transitive, this communication can't happen unless you do some things to make it happen. And like I said, that can come with more overhead. A simple way to expose that provider account service is to leverage VPC interface endpoints. Again, use the network load balancer. Create interface endpoints in those private VPCs. And now from there, what we can do is leverage DNS on-prem. The routing from over Direct Connect will know about these subnets, and then along with updating the DNS on-prem, so we can communicate directly through DNS to communicate with private provider services in this VPC. For more information, here are some resources to kind of go more in depth with VPC endpoints. I have a workshop. If you're interested in doing a workshop online, the workshop is free to go through the workshop, but you'll have to pay for the services that are used in the workshop. And also I have a nice blog post that talks about some more network optimization tips. And then we talk about choosing the right strategy for your to access S3. And then finally, we talk about VPC pricing. Thank you, everyone. Like I mentioned, my name is Lightfoot. There's my LinkedIn. Feel free to reach out to me if you have any questions after this session. Thank you.
Let's see if there's any questions in chat. Feel free to put it in there.
Any questions? Afterwards. Awesome. What's up?
I guess what are some workloads customers like using VPC endpoints for?
There's a lot of different workloads on databases. Let's say create an API. You want to solve that API. And for the VPC roundtable,
You're gonna connect the audio.
That's what can happen. Sometimes customers want to create explanations.
If there are any questions in the chat for virtual, please feel free to put it in there. If not, you're welcome to reach out to Duan Lightfoot on LinkedIn, and he'd be happy to share his knowledge with you. We'll be switching over to our lovely second speaker, George Mixella, the place to come up here. Though we had 30 registered.
Okay, I'm gonna unmute, so you should probably mute. I'm gonna start the video. And I'm gonna share screen. Yeah, can everybody hear me? Okay, so hopefully we can now see, yes. Okay, gotta get the screen hooked up.
It is sharing, but it's not sharing the full slide live yet.
Don't have to.
Now I expect
Just have the expectations of pizza and sandwiches, which are good, very good.
But now I'll make it.
That is special request.
Well, it comes to a lot of our.
You don't get to switch.
I'll do it.
I'll build.
I think we're doing all virtual this February. One, she calls me to come out and be in person, I live in Minneapolis. And all the venues are in this area. So, and I just knew mentally, like, you don't know the weather's gonna be on.
It's the rest of the time talk.
Then March, we'll have, maybe might be, supporting technology.
Sure.
You know, what they want is that they don't have it, and they have that.
Yeah.
Location's already.
For March.
So.
We are, we have a idea of like, and then they show. Yeah. I mean, it's.
No, I'm not trying to get like fiction product people.
Do you want to reshare? So it's still showing the regular slide right now. It's showing it, it's just sitting in private via inside the PowerPoint.
All right, so let me go to PowerPoint.
Oh, it's good now.
Not all of them are like that.
Still good? No, bad. It mirrored again. Damn it. All right, I can figure this out. I swear I can figure this out.
You can stop share and then just reshare. Or change the share part.
Yeah, I'll get the actor, but
Oh, there's a second. Okay,
Yeah.
I get it now.
fortunately, we can hire.
There you go.
So that's what we're sharing. And I all right, one more moment. Do not mirror, no mirror. So bad. Okay, what's sharing now?
The thinking tools.
The good,
Yeah.
oh, excellent.
Yeah.
All right. So if we just leave this guy there.
Cool. I don't even see any
All
of
right.
that.
Okay, and the sound was okay, so we're good with that. Great. All right, after far too long of a delay for technical reasons.
No worries.
Oh, come on.
I got like.
Get out of here. But I don't think, okay, we can deal with that there, right?
Yeah, we don't see it on the shared screen.
Okay. I'm George Paci. I think we covered that 6 times already this meeting. If you remember nothing else from this presentation, it's that it's pronounced Paci, like pot cheese, but only one. Okay, so that's the key point. I'll reiterate it on the last slide. How much time do I have actually?
You have 15 sweet minutes.
15 minutes. Okay, I can do this. I can do this. We have 6 thinking tools to go through in 15 minutes.
Go through and over. And again, you're the one telling us to get it kicked out anyway. So
Yep,
take
yep.
your time.
I'll try to give 2 minutes to each, and I'll try to explain what the heck a thinking tool is real quick. So a thinking tool is a tool you use to think, but not just like an outliner or a bunch of index cards or whatever. Ideally, a thinking tool should be something that changes your point of view. It gives you a new point of view to look at things from and to work with. And so you might ask, what's so great about a point of view? Well, this guy thinks the points of view are great. Yes, for the next my mouse. Technical difficulties will never stop, will they? That's just not going to happen. There we go. So you probably recognize this guy. This is Alan Kay. At what point do I just give up and say, like, the universe doesn't want me to present? All right. So he is famous for any number of things and any number of quotes. But one of his quotes I like the most that nobody seems to know is, a point of view is worth 80 IQ points, right? So not literally, but if you can get a different point of view, that can be as helpful as being somebody way smarter than you actually are, or in my case, I actually am. He actually started a project called the Viewpoints Research Institute a little while back, and you can either see that at www.vpri.org, or it might be at a new domain now. Right. So hopefully I can give you at least one new point of view with this taste of a bunch of different thinking tools. So probably the first thing to do when you're talking about thinking tools is to point out what exactly a model is, right? And you've probably heard this quote before: all models are wrong, some models are useful, right? So what this means is all models are going to leave something out. It's very important that they leave something out. If they didn't, they would be completely useless as models, right? They would just be the thing. It's like the Stephen Wright joke about having a map of the United States actual size, right? It'll take all summer to fold it. You want to be able to focus on some things and ignore other things, right? You can sometimes change things so that you can use a simpler model. So if we're going to tie this to cloud, when you spin up multiple instances of a service, right, all of a sudden you can model that thing without having to worry about, well, what if the thing goes down, right? If you just have one instance of something, you have to worry, what if somebody pulls the plug? What if it goes down? What if it crashes? Whatever. If you have 15 instances of it, the chances that all 15 are going to go down at the same time are so low that you can cut them out of your model, right? So you can have a simpler model if you can do things like, for instance, increase reliability. This one I found really, really useful. Look for the second right answer, right? So any number of times when you're programming or when you're doing other engineering or solving problems, you go ahead and you look and you say, this will work. And then you just go do the thing that will work. And even when it works, right, a lot of times later you're like, oh, I wish I had not done it that way, right? There was a simpler way to do this. There was a better way to do this. right? So when you're dealing with basically anything technical, but certainly when you're dealing with the cloud, there's probably 10 right answers, right? Given the vendors, given the different things, the original talk I was going to give was about the 206 different databases that AWS has, something like that. You've got other options. You don't have to go with the first right answer. As soon as you start looking for the second right answer or having your team look for the second right answer, then you start getting to very valuable things and very valuable other points of view on the problem. I call this one do the thing, right? This sounds like the stupidest, lamest advice ever. Of course I'm going to do the thing. I'm here to do the thing. It's my job to do the thing. The thing is there, I'm here, I will do the thing. And somehow, and I do a lot of work in government, but it's not limited to that. Somehow, sometimes the thing doesn't get done. So everybody under 40, when I say do the thing, thinks of this guy. Yes, no, right? All right. But really, what it comes from is this guy. This is Miyamoto Musashi. He wrote the Book of Five Rings. There's a bunch of his sayings also collected. He's from around 1600. And I'm going to read this whole thing because it's worthwhile, even though we're not dealing with a lot of enemy cutting in the cloud. The primary thing when you take a sword in your hands is your intention to cut the enemy, whatever the means. Whenever you parry, hit, spring, strike, or touch the enemy's cutting sword, you must cut the enemy in the same movement. It is essential to attain this. If you think only of hitting, springing, striking, or touching the enemy, you will not be able actually to cut him, right? So a lot of times we get defensive, right? We are like, we want the good thing to happen, but we also don't want any of the bad things to happen, right? And personally, I actually fenced in high school, and I wish I had known this quote because it was useful. Because you can get very into, oh, I parried really well, or, oh, you know, I got the footwork right. Well, did you hit the guy? Did you actually stab the other guy with your sword or not? Right? Because if you didn't, it doesn't matter. Nothing happened, right? So if it helps to think of it in terms of swords, think of it in terms of swords. Another way to put this sometimes is begin with the end in mind, right? So you're trying to make sure good things happen. You're not just trying to make sure bad things don't happen. Looking at incentives. So this is almost literally a different point of view. In your daily life, you see a guy, he's zipping through traffic, he cuts you off, right? Your inclination is to say, well, he cut me off because he's a jerk. I mean, I've never met the guy before, right? But, you know, it's a BMW, he's a jerk. Maybe he's not, right? So maybe the guy who cut you off, maybe his wife's in labor and he's driving her to the hospital, right? And that's why he's being so impatient, right? That's why he honked at you when there was a green light. True story, when my second child was about to be born, I honked at a guy in front of me at a green light when he didn't get going fast enough, and it was a cabbie. I was literally more impatient at a green light than a cabbie. There's a thing called the fundamental attribution error, right? And that's what we see with the guy cut me off, it's because he's a jerk. So the idea is you're attributing his behavior that you don't like to some aspect of him, right? So it might be, you know, well, my brother is just sitting around eating chips on the couch, playing video games because he's lazy, right? Or, you know, so-and-so is doing that because they're mean. Okay, well, there are things about people that do drive a lot of behavior, but it turns out that frequently it's the circumstances that people find themselves in that drive their behavior. You might see this yourself sometimes. You know you're still the same you when you're in a stressful situation and everything's going to hell and people are yelling and you snap at somebody, as you are like when you're on vacation, kicking back and you're completely mellow. It's the same you. There's not something about you that made you snap then and be mellow then. It's almost all the circumstances, right? Beyond the fundamental attribution error, when you look at organizations, a lot of times you see people doing things that are clearly not good for the organization, right? Well, you got to look at, are they good for them, right? Maybe if I'm doing a help desk my incentive is to close those tickets fast because that's what I'm being hammered on. Right? So the guy who closes your ticket without checking with you to make sure it was actually fixed, maybe it's not him, maybe it's the system, maybe it's the incentives that are being strongly brought to bear on him. So if you want to understand what people are doing, I'm the wrong guy to ask, right? But one key is look at what incentives they're behaving. This is a great one. Cynefin. It's pronounced Cynefin. It's Welsh. They decided to make everything pronounced wrong just because they don't like the English. You can't blame them. This is the classic Cynefin diagram, right? The main thing I want you to take away from Cynefin is there are different areas you find yourself in with problems, right? There are, starting in the lower right, clear problems, tightly constrained, no degrees of freedom. Here is where best practices work, right? So this is very simple systems. It's obvious what's going on. Doesn't take rocket science. You paint the wall, or you clean the dishes, or you write up your hours in the report. But then we get to complicated and complex situations, and there's a difference here, right? And this is one of the key insights of Cynefin. Complicated things are things like a jet plane, right? Probably literally a million different parts, but they all kind of work together, right? While in a tightly coupled way, they all kind of work together mechanistically. So you have some chance of understanding at least some part of an airplane and predicting everything it's going to do, right? And being able to change it or fix it or modify the design. Complex is more like a frog, right? You have all these parts, they're interrelated, but they're not necessarily interrelated cleanly, right? Something here can affect something there. Neurotransmitters from the frog's brain somehow also affect its gut and its muscles. And, so biological systems frequently are complex, but systems of people, like an organization, your company, your agency, those tend to be complex, right? And best practice is no longer going to help you here, and good practice is no longer going to help you here. So if you treat a complex situation as if it's complicated, you're going to go along, you're going to be fine, and then you're not. Something's going to fail, you're going to have no idea why, because your model of it is basically like a complicated machine and not like a complex, flexible, changing system. Finally, there's the chaotic realm where you're beyond even complex. I think something like weather would fit in here. You just don't have any prayer of predicting what's going to happen, right? So the best you can do is take some action, right? You can't like probe and then expect it to react the same way after you probe. Take some action, sense what happened. This is very important. You have to have an empirical feedback loop and then respond. So that's Cynefin. A guy called Dave Snowden is the one who came up with it. The Wikipedia page actually has a bunch of good links to things. The final tool I want to tell you about is promise theory. I keep thinking this is the year for promise theory. This is the year that people will pay attention to promise theory, because it is a very different way of looking at things. So back at Cynefin, we said you got to have the right model for things. You have to know what realm you're in. And promise theory basically says, look, we have been treating these giant systems of computers, right, as if they are a computer, right? When you have 10,000 servers, it's not like a server, right? It's that difference in number creates a difference in kind. If I had to sum up the insights of promise theory, it would basically be, look, when you have one thing and there's a 1 in 10,000 chance of there being a problem, then you get a failure every 30 years or 10 years or something. When you have 10,000 things and there's one chance a day of having a problem, you're going to have a problem. Like, does today end in Y? Okay, today is a problem day. So failures are inevitable. Another point is there's no omniscient viewpoint. Like, there's no part of your big system of 10,000 servers that knows everything about all the other 10,000 servers, right? You can't just have one node and say, you node, you will be in charge of the other 9,999, and if something goes wrong with them, you deal with it. right? Because one of the things that might go wrong with the other ones is it can't communicate with that one, right? So, okay, so we're going to have failures. We're not going to have all the information at any point in the system. So your models should take those facts into account. And so promise theory builds models not mechanistically, but it builds it out of just a few different kinds of things. You have a promise, which is not the same thing as a guarantee, right? A promise has to come from a promise maker voluntarily. It's a little complicated to explain that, but basically you can't force a promise, right? You can't say to somebody, you know, promise me you will flap your wings and fly. It doesn't work that way, right? And you can't say, promise me you'll have 100% uptime to any system, basically. But what you can say is, well, make me a promise about your uptime, right? Make me a promise that you'll give me 5 nines or 4 nines or even 1 9. 1 9's not terrible. 1 9's like, no, wait, 3 nines. 3 nines isn't terrible. 1 9 is pretty terrible. 3 nines is about what, 8 hours a year, right? So I know a ton of systems that are down more than 8 hours a year. That's manageable. We accept that there are failures and we work around them and we design systems to take failures into account and be resilient. So we have promises, they're made by the promise makers, and then they are accepted by the promise consumers, right? I make a promise, you take me up on it. Then we have assessors, because either I'm keeping the promise or I'm not keeping the promise. And someone with some amount of information, some part of the system, has to assess whether that promise is kept. Now, if I make a promise to you, maybe you're the one assessing the promise, right? But could also be Banjo assessing the promise, right? And you have a certain amount of information and you have to make your best determination of whether I'm keeping that promise, whether I'm actually up 3 nines, or whether I'm making the files available or whatever. So this seems a little complicated, but just with those 5 things, you can start describing systems in such a way that you can build in actual resilience, right? Actual resistance to failures. This really is the year of promise theory, because I heard Kelsey Hightower mention it on a podcast. And so this year, you will hear about promise theory. Right, that's just a slide to show. Okay, so here are some thinking tools. I'm happy to take any questions. We're only a little bit over.
Does the first word mean anything silent?
Oh, Kinevin, yes. That is the one with the 4 quadrants.
Does it mean anything, the word itself?
Yeah, it means something like habitation in Welsh. Something like, I don't speak Welsh. I don't think that's rare, but yeah, it's supposed to be habitation or place of habitation. Yeah, I mean, basically to me, it just means Kinevin, that thing that Dave Snowden talks about.
The theory is very interesting.
What
Good.
are some ways to, I guess, identify what type of system something is? Like complicated, chaotic.
Okay, we'll flip back to the Kinevin slide. So if you're actually getting good practices to work, so best practices always do this, always do that. You do that in clear situations because it's clear. Good practice is, well, you know, if you have this thing, try that thing. Or if you can see this other situation, try this other thing. And so what you can do there is you can look at the parts of the plane in front of you. You can sense them. You can think about what the parts are and how they work together. And you can say, oh, okay, I know what to do. I plug this thing into that thing and I pull this one out and I replace it. And if that's working for you, then you're in a complicated situation, right? However, if that's not working for you, you pull something out and then something else pops up in its place and you're like, wait, what? Then you're stuck probing, well, not stuck, but then you have to probe, sense, and respond. Things aren't sort of standing still in the frog for you to get a good look at. You got to probe, you got to, like, you know, push on this vein here in the frog and see what happens. But then you sense, right? You actually have to collect the information from what's going on in the frog and say, oh, well, when I do that, you know, this leg of the frog goes cold and this other part of the frog, you know, it gets all filled with blood. All right. And then you respond. You say, okay, well, now I know that is the vein that supplies the stuff to there. But yeah, generally 50% of the time, if somebody's got a situation, they have a nice detailed model of what's going on, they do what the model tells them and nothing works anyway, it's likely that they think they're in a complicated situation, but they're actually in a complex situation.
Okay, so you can kind of move things back once you figure out more system, try to make another model.
Yeah. Another thing you can do, Matthias Eifert talks about this some, is sometimes you can kind of draw a boundary around part of a complex system and then treat that as just a complicated system. But even drawing a boundary and saying, well, this part of the frog is completely different from that part, or this part of the organization is completely separate from that part of the organization. Until it isn't, oh, wait, you have a system that talks through a backdoor to that part of this system, and now it's blowing up. Yeah. Okay, thanks for your time.